All right, so I want to kind of slow down and redo this video that I did earlier today in class, just so that we can get just a little bit better handle on what we're doing and not be so rushed, okay? So for starters, obviously this is 8-10. This is system of equations, so this is a new concept. We're going to be using what we know about graphing linear equations from earlier in the chapter, but we're going to be applying it to a new concept called system of equations. So since it's new, I want you to pause this video and I want you to write down first the definition of a system of equations, which is when two or more linear equations are graphed on the same graph. The solution to a system of equations, if there is one, is the point, which you're going to write as an xy coordinate, where they cross. And then there are three possible solutions to a system, okay, or a system of equations. The first is one solution, which you would write as an ordered pair with an x and a y. That's where the two equations intersect. The second possibility is no solution because they'll never cross because they're parallel lines. And then the third possibility is infinite, which means they're basically the same line. They have the same slope, they have the same intercept, they're the exact same line. And so the solution, which is the points that they share, is infinite because they share every single point because they run right on top of each other forever, so they share infinite points. So in a one solution, they share one point where they cross. A no solution, they share no points because they're parallel. And infinite is they share infinite number of solutions because they are the exact same line and they run right on top of each other for an ever and an ever and ever, okay? So I want to work a few of these with you. Notice the instructions. It's really important that you read the instructions every time. Notice our first instructions are to solve each system by graphing. So they want you to graph each line and then see if they cross. Okay, if they do, your answer is an XY. If they don't cross, they're no solution, and if they are the same line because they run right on top of each other, then it's infinite. Okay, so the first is graphing. Now notice that tells you to graph it, so they give you a graph. If they don't give you a graph, they're not going to ask you to solve by graphing because you cannot do hand-drawn graphs here. They never line up and you never get the right solution, okay? The other thing to notice here is that your x and y coordinate, notice it is divided up by 2's, right? So it's 0, 2, 4, 6, 8 along the x and 0, 2, 4, 6, 8 along the y. So if it helps you to come in here and fill in the gaps here, this would be 1, whoops, sorry about that. There we go. This would be a 1 right here. This would be 3, right? This would be 5. Going up, this would be 1. This would be 3. This would be 5, okay? So because it goes by 2's, you need to kind of fill in the gaps there to be able to graph these correctly. All right, so first things first, we are going to graph this first line in blue, okay? We always begin by plotting our B. So I'm going to go up. This is where the work that we've done so far in Chapter 8 comes in. So we're going to go up to 3, which is right here, and we're going to put our beginning point. Okay? Then we are going to use our slope, which it's here, but it's not here. It's right here in front of the x. There's always a 1, and we can put any whole number over 1. So 1 over 1 is our slope. So we have our b, which is 3. We have our m, which is 1, and our m tells us to move up 1 over 1. Okay, and be careful here. You going up from 3, up 1 would be up to 4. Going over 1 or running 1, you would run halfway to 2, which is right here in the middle. Now, once you have 2 points, you can draw a nice straight line. Now, you have to use a straight edge here. You have to use a ruler, or I don't care if you use a Kleenex box or one of your mom's lids out of her drawer or anything at all that has a straight edge. But these have to be straight lines. You cannot hand draw these because if you hand draw them, you're going to end up off and your intersection point is not going to be correct. All right, so we're going to graph this first one in blue. So we're going to go, and we want to stretch all the way across our graph, right? So we've got a nice straight graph. Now we're going to go to our second one. I'll do that one in purple. And we're going to graph this second one in purple, okay? So, again, we talked about this on Tuesday. We got to get used to seeing it like this. Remember, it's y equals mx, and then plus b is here, but it's It's nothing there. So you need to know that it's plus 0. So the b here is 0. Your y-intercept, or your beginning point, is at the origin. So we're going to put a point right at the origin. And then our slope is 4 over 1, right? So from our origin, we're going to rise 4 and go over 1. And again, be mindful, going over 1 means halfway between the first line and the next line in the grid. And as you can see, we went right over the top of one of our blue points, so that tells us that is its intersecting point, or the solution. So let me go ahead and finish off here by drawing my purple line. And I'm going to go up this way, and then I'll go down this way. All right, so there is the two lines graphed. But that is not the answer, right? The answer, or the solution, is the point written as a coordinate, or a coordinate point with an x and a y, of where they cross. Well, here's where they cross, and that is the point, right? Look up, straight up from the x. It's the point 1, right? Right above the 1 on the x-axis and over to the 4. So your actual answer here that you would circle is the point 1, 4, okay? All right, so let's move on to this example. All right, so we're going to start off by graphing this line in blue, and we begin with our b, which is -3. And again, look at your graph. It's 0, 2, 4, 6, so -3 is right here in the middle. And if you look at my slope here, again, it's 1 over 1, right? If there's nothing behind a variable, it is a 1. The coefficient is a 1, the number attached to it, or whatever, however you want to think about it. But if it's not there, it's 1. So we're going to go up 1 over 1, and again, you got to really think about the placement of the numbers of your line. So we go 2, 4, 6. So halfway between two lines is a move of 1. And we are going to do our line here. So we're going to do a nice straight line this way, a nice straight line this way, and that one is graphed. Now let's graph our second one in purple. We're going to go +3. Well, we're going to go up to the 3. So notice our slope here. Same slope, different y-intercepts. So kind of keep that in mind. Same slope, different y-intercepts. Look what happens. Our slope is up 1 over 1. Okay, and we are going to graph this line in purple. Okay, so now we're going to go up, and we're going to go this way. Notice what kind of lines this creates, right? These are parallel lines. So the solution is where they cross. Are they ever going to cross? The answer is no, they're not, because parallel lines never ever cross. So the answer that you're going to circle here is the words no solution, because there is no shared point, okay? There is nowhere where they cross. All right, for number 3, I want to look on your homework to see if you have any like this before I worry about doing one of these in the example. Okay, you don't have one like this, so I'm going to skip this one. But I do want to cover something that you do have in your homework, and that is one like this. Okay, let me erase all this because I actually worked this earlier. Now let's do this. Okay, so I made a note here that one of the things you have to do is, in order to, when you have a fraction like this, you really want to get rid of the fraction, okay, especially when it's on the y, because you can't really graph this until you have it in y equals mx plus b. And right now, in both of these equations, the y is not by itself. So you need this in just plain old y equals mx plus b. And right now, in both the top and the bottom equation, there is something attached to the y. We have to get rid of that, okay? Now, to make a fraction reduce to a 1, which is what we want, because we want the number here in front of this a 1, right? We want it to be not there, which means it's a 1. So in order to make 1/2 equal 1, we have to multiply it by 2 over 1, or 2, right? So we have to multiply the fraction by its reciprocal. Well, if we multiply this whole thing right here by 2, that means we have to multiply every term by 2, okay? Because those are the rules. If you do to 1, you have to do to all 3. So we're going to multiply every term in this equation by a 2. So I'm going to cross this out, And when I do that, they cross-reduce to a 1, and what is left is the y all by itself. When I multiply 4x by 2, I get 8x. And when I multiply negative 6 by 2, I get negative 12. So that takes care of the first equation. Now I'm going to drop down to the second equation, and I'm going to do the same thing, only this time, to get rid of 1/4, I have to multiply by 4, which means I have to multiply this term by 4 and this term by 4. And I'm going to rewrite this now with my everything reduced, which again, this is what I wanted. I got that reduced to a 1, so on my y is all by itself, right? Or there's a 1 in front of it, but we never write that. So y equals 4 times 2 is 8 for 8x, and 4 times negative 3 is negative 12. Now you should notice right off the bat that these are the exact same equation, okay? Same equation, right? And we've talked about what this means, but I'll go ahead and graph it just to show you. But you have y equals 8x minus 12 and y equals 8x minus 12. They're the exact same equation. So I know right off the bat that my answer is going to be infinite, because the very definition of infinite is that they're the exact same line, and so when you graph them, they're going to look the exact same. But let's go ahead and graph this. All right, so if we graph the top one, doesn't matter which one we pick, they're identical. We go down to negative 12, which is about right here, right? Look at the way your lines are spaced out. It looks really weird, but if that's negative 5, then that one's negative 10, which means negative 12 is going to be about right in the middle. Then our slope is right here, 8 over 1, right? 8 over 1. So we're going to rise 8 from negative 12. We're going to rise 8, which puts us at about negative 4. And then we're going to run 1. So run 1. Nope. That's a little bit more than 1, isn't it? Because that space is 5. So run 1 right there. And it really doesn't matter that your graphing is perfect, because you already know the answer. You already know that it's infinite. But let's go ahead and draw our line. So our line here that connects this is here. All right? That's our line. Now, I could take the time to graph the second one, but guess what? It's the exact same thing. It's a point here, right? It is, sorry, it's a point right here where your y-intercept is, and you're going to go up 8 and over 1, and there's your other point, and when you graph the line, it's going to be right there on the exact same one. So when you have identical equations, they're going to graph right on top of each other, so your answer is going to be infinite, okay? All right, this one looks a little weird because there's some missing information, but it is not weird, okay? We have talked about this before. First thing, think about this top one. If I want to graph this top equation, this one right here, right? If I want to graph that, I need an M and I need a B, right? Well, it's there, but it's not there. It's all a bunch of hidden information, but it's there. Think about this. It's y equals mx plus b. So our m here is the number that's right behind the x. Well, it's there, but it's not. It's a negative 1. So our slope is negative 1 over 1. And then we've already talked about this, but plus b, right, if it's not there, it's a 0. So our b is 0. So to graph the blue line, we're going to put a point at the origin. And then we're going to go, and again, look at the way everything's numbered. Everything's by 2's. So if I'm going to go down 1 over 1, that puts me right here, right? I went down to 1 and over to 1. And I can draw my line here. Like this. And let's go this way. All right, so there is the blue line. Now I'm going to come over here and I'm going to do my next line in purple. Well, it's pretty easy. I don't even have to do any thinking here. There's my B. So plus 6 up to 6. And again, my slope here is 1 over 1. So I'm going to go up 1 to 7 and over 1. So there's my up 1 over 1, right? I went up 1 over 1. And for my purple line, let's draw that. All right. Now, your crisscross, your intersection is always going to be right at a crisscross, right? So my lines are not exactly perfect. So right there is my crisscross. Put it right on a intersection so that you can name the point. Because they're not parallel, they're not the same line, they do intersect. The answer has to be the point where they intersect. And the point where they intersect is over to negative 2, right? So if you look at right here, If we go to look at the x, it's -2, and then the y is +4. So the answer here is going to be the point -2, 4. Backwards -2, up 4 to get that coordinate. All right, so that is some practice on graphing these, and we did see an example of both parallel lines, the same line, and when they intersect, okay? Now I'm going to go back to my notes. Now this was actually on your homework, so if you're watching this video, and that tells me that you watched the video because I just did 2 of your homework problems with you. All right, let's jump back to the notes now. All right, so let's look at the next step. So the next set of directions change a little. Notice here it says solve each system of equations by substitution. Well, this is a different method. Notice they don't give you a graph, and you can't hand draw a graph because they're never going to be to scale, so they're never going to be a true line where they intersect. So you have to do it with a different method, and that method is called substitution. With substitution, they are going to give you an equation, and then they're going to give you a second equation, but that second equation is going to be more like simpler, okay? So if you'll notice on every single one of these, the second equation here, 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 it's a much simpler equation, okay? So you're going to use that second equation to solve this by substitution, okay? So here's what you do. You take the simple equation and you put parentheses around what they tell you. They tell you y equals 4. So that clue or that information is that y equals 4. Well, we're going to substitute that. We're going to come up to the other equation, okay? Where there's a y, we're going to put a parenthesis because it's about y here. This information is about y. Y equals 4. We're going to find the y in the other equation, and we're going to substitute 4 in place of the y. This is why it's called substitution. So we're going to, in this top equation, where there was a y, we're going to substitute 4, and then we're going to just write the rest of the equation just as it is. So y equals x minus 2, and my clue about y is that it's a 4. Now let's solve for x and see if we get an answer that makes sense. Well, to solve for x, we already know the y is 4, right? We already given that. So to solve for the x, we're going to add, because it's a -2, we're going to add 2. And whatever I do to one side of the wall, I do to the other. And so I get that x equals 6. Well, because I got a nice clean answer that makes sense. I have an x and I have a y value. Since I have an x and a y value, I am able to write my solution as the point x equals 6, right? So 6 goes in the x spot, and they already told me that y equals 4, so 4 in the y spot. Okay? So this is your equation or this is your solution to this system for number 4. All right, this number 5 is identical to that. I'm not going to work it all the way through. They tell you y equals -5, find your y, substitute it in, solve for x, and then you will get some x value, and then we already know that y equals -5, so you'll add your x when you solve for that, okay? Let's see, I want to do a couple that are a little bit unique so that you're ready for that on your homework. Let's see, do we have one? Yes, we have one like this on your homework. All right, so this tells you, this clue, right? The short one is always your clue, right, or your information that you're going to use. So this clue tells me that y equals -x. Well, I'm going to go up to my other equation, and I'm going to put a parenthesis around y, and then I am going to substitute -x in the place of y. So I'm basically going to put the -x here. Okay, so that's a nice way to look at it. So with everything substituted in, what I'm going to be solving here is -x equals 5x plus 12. Okay? Now, to solve for x, first of all, the first thing I have to do, this goes back to the beginning of the semester when we talked about solving equations. Here's my wall. I need to get all my x's on the same side of the wall, okay? So I'm going to move this 5x over to the left to be with the other x that's over there. So to do that, I'm going to subtract 5x and subtract 5x, okay? This gets all of my x's together on one side. So that cancels out. My equal sign or my wall still stays in the same spot. And over here I have nothing but 12 left. I have -x and -5. Remember, this is really a 1. So -1 minus 5 is -6x. And now I want to get x all by itself. It's multiplication, so I use division to get it by itself. And my answer here, when that reduces, is x equals -2. Now, remember that your solution, right, is an x and a y. Well, I now know that x is -2, but I don't know my y yet. But I have an equation, which was my clue, that I could use to find y, all right? Y equals, now, I've got the negative sign, so now I'm actually going to have to erase this because now I'm going to have to put the parentheses in a little bit different place. But now I want to plug in, right? Now I want to plug in because I now know that x equals -2. So if I plug into the equation y equals -x, I now know that x equals -2. I found that out over here. So the only thing I have to do here is distribute, really this is a -1, right? So -1 times -2 is +2. So when I come over here to my answer, I'm going to put a +2. I'm going to put a +2 in for the y spot because that's what I got right here. And so now my answer is the ordered pair that the x is -2 and the y is +2, right? I got that from doing all this work, but this is my, right here, this is my final answer, the ordered pair -2, 2. So you have to first substitute, using your clue to substitute into the first equation, then you have to solve it and take that information, figure out what you're still missing, and then find that. It's kind of like a puzzle. You're given some information, you're missing some information, and you have to figure out what's the best way to find all that information, okay? So this time your clue, right? Remember I said the more simpler one is your clue. My clue says that x equals 0. So if x equals 0, I'm going to go up to my top equation, I'm going to find the x, and then I'm going to substitute 0 in for, right? I'm going to substitute my clue that x equals 0 into the other equation where there's an x, I'm going to put a 0. So the equation I'm going to solve here is y equals -2 times 0, which we know is 0. So now I have a y equals and an x equals. I have everything I need to write my answer. X equals 0 and y equals 0. So my answer is the point 0, 0. So if I were to graph these two, they would crisscross at the origin. All right, let's see. Anything a little bit different that you might see? Yeah, let's do one like this. Last one I'm going to do here. All right, so again, look at your clue. It's always your simpler equation. So my clue says that x equals 4y. So since the clue is about x, I'm going to find my x in my first equation, and I'm going to put 4y in for x. Can't really fit it in there. So I'm going to insert or substitute 4y for the x because my clue says that that's what x equals. So I'm going to come over here and I'm going to write y equals 4 times, now I'm plugging in, right here, I'm plugging in 4y. I got that from here, plus 45. All right, so y equals 4 times 4 is 16, so that's 16y plus 45. Now you got to think about it, right? This is your wall, and I want to get all my y's together on the left. So I need to get those 16y's over there. So I'm going to minus 16y and minus 16y. Whoops. And when I do that, I have a positive y, that's a 1y, minus 16y gives me minus 15y, or negative 15y, because 16 is negative, a 1 is positive. When the signs don't match, you subtract. I'm going to clean this up just a little bit so it doesn't look so weird here. There we go. When you subtract, if you're negative 16 and you only come up 1, you're still negative 15. Okay? And then that is now gone, which is what I wanted, plus 45. And I need to still get y. I need to solve for y here. That's my goal. So I'm going to divide by negative 15 and divide by negative 15. And I get that y equals negative 3. When you put in your calculator 45 divided by 15, you get 3. So I know part of my puzzle, right? And if you're thinking about your answer here, your answer is going to be an ordered pair with an x and a y. Well, I now have found part of my puzzle. I know that y equals -3. I've got part of it. But I still need to know what x equals. Go back to your clue right here and you've got x equals 4 times, well, what's our y? Our y is -3. We already know that now. So that means x equals -12. So I'm going to put -12 in here for my x, and that is what you circle as your answer. And that's kind of cramped in there, so it would be -12, -3. That's your ordered pair that is the answer, okay? Use your clue, substitute it into the other equation, solve for the variable that's there, use that, plug it into your clue to find your other variable, okay? I know it's a lot of steps. If you are a person who likes to write out your steps, you certainly can write this out in your notes. Step 1 is to find your clue, right? And that's usually the simplest. Oops. It's usually the simplest equation of the two. Step 2 is you're going to substitute your clue into the other, and that's what's really important, into the other equation. Step 3 is you're going to solve for the variable, and sometimes it'll be a y, sometimes it'll be an x. Step 4 is to plug the solution from step 3 into your clue equation. Okay. Step 5 is to solve for the variable. And if you solve for x the first time, you'll solve for y in step 5, right? If in step 3, if you solve for x, you'll solve for y in step 5. If you solve for y in step 3, you'll solve for x in step 5. So it just depends which one you solve for in step 3, you'll solve for the other one in step 5. And then, let me move this up because there's one more step here. Oops. Here we go. Okay, the last step, step 6, is to write your answer. Whoops. Helps to spell answer, right? Write your answer, right, as an ordered pair with the x you found and the y you found, and that's what you'll circle as your answer. Okay? All right. I want you to try your homework after you watch the video and write your answers as an x and a y, okay? Follow these 6 steps, and hopefully this helps. If you have any other questions after watching this video, shoot me an email, and we will go over this more in class tomorrow. If you're not here tomorrow in class, shoot me an email, and I can open up a video, and you can listen in while we talk about it in class, or I can open up a video one-on-one with you during my prep. All right. Hopefully this helps. Hopefully you have a good night, and I will see you in class tomorrow or when you get back from being at home.